Hi, this is Anil Bhatia and welcome to another episode of TR Insights. If you look at migrating SQL Server instances to the cloud, it requires a lot of planning for both high availability and disaster recovery. And there's so many infrastructure as a service offering that it becomes a big challenge for customers and users to pick and choose, what is best for your environment. So today we have with us Dave Bermingham. You are technical evangelist with SIOS Technologies. So Dave, if you look at all the configurations that companies are using to protect their SQL Server while keeping up with their business requirements, do you have some tips or tricks up your sleeves to kind of protect that in the context of high availability and data recovery? So tell us about the options that customers have there.
Before we begin, we probably should define, what high availability is, because it can mean different things to different people, right? And the cloud infrastructure in itself, if we're looking specifically at infrastructure as a service, so you're managing the instances, you're managing SQL Server, so it's incumbent upon you to make sure that it's running. But the underlying infrastructure does have some level of service guarantee or service level agreement. So if you deploy a single instance of Windows Server and SQL Server, the infrastructure of that single instance is guaranteed at 99.9% availability. However, high availability doesn't really come into play until we start talking about 4 nines of availability, which is about 52 minutes of downtime per year. To achieve that 4 nines of availability, the cloud service providers give you the option to deploy multiple instances of your operating system or multiple virtual machines across different, each cloud service provider has a different name, but think about availability zones, available in AWS or Azure, or simply zones in Google Cloud Platform. But to get that 4 nines of availability for the service level agreement, you need to deploy your instances so that you have at least 2 instances, and each instance residing in a different availability zone, which turns out to be a different data center. And so once you've done that, then your infrastructure is guaranteed at the 4 nines of availability. But what that doesn't cover is the actual applications running inside those virtual instances. So you still need to account for the availability of those of SQL Server that we're talking about today. So to do that, you can leverage much of the same technology that you've been leveraging on premise for many years, and that really boils down to the SQL Server failover cluster instances, or the always-on availability groups. And by leveraging, that type of technology, you will monitor the availability of SQL Server, and should it become unavailable, whether at the entire instance layer or at the service layer, any area where it becomes unavailable, those technologies will detect that type of failure and will initiate a failover to the standby server to make sure that you have the availability of your SQL Server instance.
What are some of the best practices? You touched upon it a bit, but is there a playbook that people can follow for their configuration in the cloud?
The challenge with the cloud is, always-on availability groups has the replication built into the technology. So the challenge in the cloud, when you're talking about not in the cloud, anytime you're talking about a multi-data center type solution, the challenge comes into making sure your data is available across all the different data centers. So the always-on availability groups has some functionality built into it to replicate that data between the different instances of SQL Server. So I could do that synchronously within the same data center. Or when we're talking about the cloud, synchronous can be used within the same region, but between different availability zones. And by using the synchronous replication, you can also enable that high availability failover clustering, the high availability automatic failover and recovery, which is required for high availability. Now, when you start talking about SQL Server failover cluster instances, traditionally that is a single data center only type solution because it would require some sort of shared storage device. So whether it's your fiber channel SAN, your iSCSI, or even in the later versions of SQL Server, you can leverage SMB3 shares. But all that data normally resides in a single data center. So stretch clusters or multi-site clusters require some sort of replication technology that is not generally offered by the application or the operating system. Now there is a solution that was introduced in Windows Server 2016 called Storage Spaces Direct, which eliminates the need to have a shared storage device and instead allows you to leverage just local attached storage, and it takes care of the replication and creates kind of a virtual storage bus layer that kind of mimics the SAN. But even that solution, you have to be careful if you're considering that using that in the cloud. That still is a single data center solution, so it's not even supported if you want to span availability zones. So, and this holds true for Azure when you're going between availability zones, or AWS availability zones, or even Google zones. Google's interesting in that zones are not very well defined. And if you do some research, you'll find that sometimes different zones will be different data centers, but other times maybe not. So you have to be very careful that if you're using S2D in any of those environments, that your nodes all reside in the same data center. The challenge with that is then you don't get the 4 nines of availability with your infrastructure. So with, for instance, if you want to do that in Azure, you would leverage something called fault domains, which instead of different data centers, they're typically, you think of it like different racks in the data center that have some resiliency, and there's no single point of failure between those racks. But if you're not leveraging the availability zones, Microsoft's only giving you 99.95% SLA. So that typically falls below the bar of high availability. So you have to look at the solutions. There are new solutions that are coming out, some SMB3 options, and you have to be very careful when you look at those as well. So in AWS, you have the FSx service, which offers a SMB3 share, and Azure Files can also be leveraged to have your backend storage be an SMB3 share. But if you look at the SLA for those storage offerings, they're typically 3 nines, 99.9%. So you've gone through the entire process of making your virtual machines highly available, 4 nines of availability, but then you just put your storage on something that's 3 nines. So effectively your cluster is back to 3 nines of availability. So why did you go through the whole process of clustering your instances when your storage is only 3 nines? So you really have to look very closely at all the, at every part of your cluster to make sure that you have, those 4 nines you're striving for in availability. Now, not every application needs 4 nines, right? So you might have some database SQL Server instances that are not quite as, business critical. So, single instance, 3 nines of availability with a good backup solution, a good disaster recovery solution might be sufficient if your recovery time objective is hours, recovery point objective is, minutes. Then, there's solutions out there. So not every instance needs a 4 nines, but if you do have that business critical instance that needs the 4 nines, you have to be very careful at what you're looking at. So S2D is one option for the SQL Server failover cluster instance. The SMB3 share is another option for those instances. And then there's third-party storage replication solutions that will give you this synchronous replication and integration with failover clustering, which overcomes some of the limitations around the S2D because it's not limited to a single data center, and also will allow you to, doesn't box you into the 3 nines of the SMB solution. So some of those third-party solutions can sometimes be better options for deploying failover cluster instances. So it really comes down to, do I want to deploy availability groups versus do I want to deploy failover cluster instances? And there's benefits to each. Availability groups gives you gives you high availability and gives you some stuff like readable secondaries, which can be beneficial in some scenarios. But it also comes with the price of SQL Server Enterprise Edition. And, the alternative, the SQL Server Failover Cluster instances, you can run with the SQL Server Standard Edition, but you don't get the readable secondaries. However, it does, it replicates the entire instance. So things like your agent jobs, your logins, your passwords, everything gets replicated. Some of that stuff gets left behind with the availability groups. So it really depends on your requirements when you're considering which way to go for availability in the cloud.
I'm also curious, you must have come across a lot of, typical mistakes that you see there and that you would want users to avoid.
Some of the mistakes or I would say challenges, maybe just they're not unaware, right? So, and it's, first, when I deployed my first cluster in AWS, I built it and it looked just like my, kind of went pretty smoothly, just like my on-prem cluster, and but it wasn't working in that my clients couldn't connect to my cluster. And so I was kind of scratching my head. Again, this is very early on, so hopefully, as long as you're reading the instructions, you shouldn't run into this. But this was kind of a new frontier for me back a few years ago. And so a lot of the challenges come around the networking. So each cloud service provider will have different challenges in the networking stack when it comes to offering high availability. So I'd say AWS and Google Cloud Platform are similar in that, they're all similar in certain ways, but the challenge I had like with AWS was I didn't first off, if you're failing between availability zones, you're building what's called a multi-subnet cluster. So each node is in a different subnet, which means that you can't have a single virtual IP address as your client access point. You have two IP addresses. And so that might be new and challenging configuration that you're not accustomed to on premise. And there's a lot of good information out there about how to configure that and some challenges you might have with the application actually leveraging two IP addresses. So you want to roll up your sleeves, do all the reading that you can on multi-subnet clusters, things like register all providers IP. Just give me some keywords to Google on multi-subnet failover equals true, which is if you put that in your client connection string, it basically tries both addresses at the same time, and only one of those addresses are online. But not every application will support those types of things. So you have to really do a lot of investigation. If you're doing that multi-subnet failover, Azure has an entirely different challenge in that the network does not support gratuitous ARPs. So even though you have a single virtual IP address and you think I'm just going to connect to that virtual IP address, if that's all you do, you're going to find that very quickly that your applications, your clients can't connect to your SQL Server instance. And so if you read the documentation, you'll quickly find that you need to use a load balancer. So a cloud-based load balancer, and then your client's configured to connect to the load balancer, and the load balancer will redirect you to your active instance. Again, that all comes down to the cloud network not supporting gratuitous ARPs. So that address doesn't get updated in the ARP table. And so using the load balancer is configured with a probe that probes each node to find out which node is active. And so your client connects to the node, and then your client connects to the load balancer, and then the load balancer redirects it to the active node. So those are most of the challenges that I see people having with the initial configuration. The second biggest challenge comes down to security. And there are various levels and layers of where security can be applied in the cloud, starting with the Windows firewall, of course, but then there's cloud-based security that can be implemented or not, and you may not always be aware or be the person responsible for implementing security. So you have to work with the entire team that's building your cloud infrastructure to make sure that the security, the ports required between the instances will be open. And also things like, if you're implementing a load balancer, there's a thing called a health probe from the load balancer. You need to make sure that that port is open from, so that the actual load balancer can probe that port. So that's typically security. If they read the instructions for the networking, they got beyond that, then the other challenges that I commonly see are all security related. So you're going to really want to make sure you understand what ports you need open and where are the different layers that things can go wrong.
Talking about challenges and going back to SQL Server, what about shared storage? So what are the challenges there? Also considering the networking requirement, and how can those be addressed?
Again, it comes back to the networking challenges that we're talking about, and sometimes you have some options. So, Azure is pretty straightforward. When you're in a single region, you have a single load balancer. If you configure it properly, it can redirect your nodes to redirect your client connections to the active node. But what if you want to implement a cluster that spans regions in Azure, or even spans on-prem into Azure? Then you have other challenges because the load balancer can't redirect a connection to your instance that's on-prem. It can't even redirect the connection to a different region in Azure. So now you're combining multiple technologies in that you would have a load balancer for, say you had 2 nodes in Azure East, and then you had a third node in Azure West for disaster recovery. You want to have something a little bit further away from a single region, for disaster recovery in case an entire region had a power failure or whatever it might be, some natural disaster. It's always good to have, in many cases, that DR node. So in that case, you would have a load balancer in the east to redirect to the 2 nodes locally. But what if those 2 nodes are unavailable? Then you're going to have to go back to, you're going to be configuring a multi-subnet cluster. So like I was saying earlier with AWS, where it's always multi-subnet, in Azure, you might have a multi-subnet cluster if you're leveraging multiple regions. So now you have to have a load balancer in the east and a load balancer in the west. Even though you might only have a single node, you still need that load balancer because you can't connect directly to the virtual IP address on that node. And in addition to all that, now you have to configure your clients so that it might use that multi-subnet failover equals true, so it tries both regions at the same time and it will only connect to the active region. So many different variables that you come into play. Again, where do your applications reside? If they all reside in the east, well, hopefully you also have disaster recovery for your application servers as well. So they should be available in the west region. So there's lots of different things to consider when you're building complicated configurations like that. But networking is probably the biggest challenge. And again, it really comes down to what you're trying to build: hybrid cloud, multi-site, multi-region. And so there's lots of options there. So we've been talking a lot about infrastructure as a service. So this is managing your own instances. If you're looking, there's obviously other options available to you, from Azure managed instances to platforms as a service, and those options will have typically availability as a checkbox. Do you want to have high availability? Do you want to have disaster recovery? And if you do, this is how much extra is going to cost for that. Whatever your options are, you really want to make sure that you are covered in any conceivable disaster recovery or failure scenario you can imagine. You know, again, if you're leveraging platform as a service and they have a service level agreement, that's great, and you hope that they're going to keep your instance up and running. But there's always that scenario where something really, really unexpected happened, and then all of a sudden that service is not available. And we've seen it, you know, in the most basic platform as a service, you know, your hosted email account, right? If you hope that they're taking care of making sure that's available. But if it's not available, it's nice that you have, you know, some of your emails cached locally, so you have that option. And if it's an extended outage, you might want to have, you know, a plan B. If I was managing, you know, if I was in charge of my email for a large corporation, we were leveraging, you know, some platform as a service, you know, I want to have that kind of worst case scenario to redirect my email to a local email server, just in case something really happened that was an extended outage. Same with your SQL Server infrastructure. You really have to plan for the worst. Hope that it never happens. But if it does happen, you want to know, you don't want to start thinking about what to do at the time that it happens. You want to have that plan in your back pocket to say, well, I planned for this day, and here's how we're going to keep business up and running until we get this straightened out. So just always plan for the worst. I don't think you could ever do too much planning.
Awesome, Dave. Thanks for sharing all these tips and also some warnings there. You know, the precaution or some of the mistakes that they should not make. And I look forward to talking to you again at some point. Thank you.
All right. Thank you.